Hello everyone, and welcome to your Chem 113 review on Avogadro's number. My name is Jason, and I work for the ASU Tutoring Centers. We have finally been introduced to the mole, MOL. It is a unit in chemistry, and I like to think of it as sort of the great equalizer in chemistry. So you can describe so many different things using a mole. You can say you have, 10 moles of molecules, or of atoms, or of compounds. Basically, anything you can think of in chemistry, you can describe the amount of that thing you have using moles. So what a mole is 1 mole of something means we have 6.022 times 10 to the 23rd of that thing, whatever that thing is. This is what Avogadro's number is. It's a very famous number. It's a very important number. Make sure you know it. Okay, Avogadro's number. So if I say I have 1 mole of carbon atoms, that really means I have 6.022 times 10 to the 23rd carbon atoms. If I say I have 1 mole of the molecule NH3, then that means I have 6.022 times 10 to the 23rd NH3 molecules. So you see, it doesn't necessarily have to be talking in reference to atoms or molecules. It can be used for either one. Really just any sort of microscopic thing that you have, you can describe it in terms of moles, okay? But dealing with 6.022 times 10 to the 23rd of anything is just really complicated to do. So we use mole instead. It's a lot nicer to look at 1 mole than it is to look at 6.022 times 10 to the 23rd carbon molecules, right? Okay, so the mole is the great equalizer. So in our particular problem, we want to calculate the number of hydrogen atoms in 0.35 moles of C6H12O6. So imagine we have 1 mole of C6H12O6. Let's just imagine. We have 1 mole of C6H12O6, glucose. I mean, possibly glucose. They didn't tell me that, but I'll just assume. So suppose we have 1 mole of it. So what does that mean? We have 6.022 times 10 to the 23rd molecules of glucose. C6H12O6, okay? So within each of those molecules, within each of those individual molecules, we have 12 hydrogen atoms, right? Every molecule of C6H12O6 has 12 hydrogen molecules, has 12 hydrogen atoms, right? So if we have 6.022 times 10 to the 23rd molecules of C6H12O6, that really means we have 12 times that hydrogen atoms, right? Because there's 12 hydrogen atoms in each molecule. But then reducing this down, 6.022 times 10 to the 23rd, that's 1 mole. So we have 12 times 1, in other words, we have 12 moles of hydrogen atoms. So for every 1 mole of C6H12O6, we have 12 moles of hydrogen atoms. And in general, that's how that always works. That conversion always holds. You just use the subscript on your atom. So 1 mole of C6H12O6, you could also say corresponds to 6 moles of carbon. It also corresponds to 6 moles of oxygen. All you have to do is use the subscript. So this is going to be an important way to sort of transition between talking about the glucose molecule and talking about the individual hydrogen atoms. Okay, so if we have 0.350 moles of C6H12O6, well, we have that conversion that we were just talking about. Let's use our little picket fence method. For every mole of C6H12O6 we have 12 moles of hydrogen, right? I should specify. I'm not just crossing off moles here. I'm specifically crossing off moles of glucose. So we've now converted from moles of glucose to moles of hydrogen. And now we're looking for the number of hydrogen atoms. That's where we need to use Avogadro's number, right? So Avogadro's number tells us that 1 mole of hydrogen corresponds to 6.022 times 10 to the 23rd hydrogen atoms. So here the moles of hydrogen cancel out, and we're left with the amount of hydrogen atoms, which is what we're looking for. So when we do this multiplication across the top and we reduce it, it ends up being 2.53 times 10 to the 24th hydrogen atoms. Okay, so big lessons here are Avogadro's number you use to convert between moles of things to either molecules or atoms or whatever it is you're talking about. And then the other important thing is within a compound or a molecule like this one, the number of moles, if you have 1 mole of that molecule, the number of moles of each individual element corresponds to its subscript. So every mole of C6H12O6 corresponds to 12 moles of hydrogen. Those are the 2 important takeaways. All right. Well, thank you for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. If you want more information about the tutoring services we have available to you on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. By going here, you'll open up our tutor search feature, which will be able to connect you to a tutor, either in person or online on your campus that can help with your specific course. Thank you again for watching, and I hope you have a wonderful day.